This image shows workers balancing precariously on the exposed upper edges of a concrete flyover under construction. Working on towering structures like high-rise buildings, chimneys, and expressways involves an immense scale and an ever-present inherent danger. A human falling from a standard duty height of up to 6 meters generates a massive, potentially fatal amount of kinetic energy. Duty height is defined as the maximum vertical distance between the worker's active level and the safety net placed below them. To counter this, the IS 11057 standard acts as a strict, unforgiving gauntlet of physics and material science designed exclusively to guarantee a worker's survival. The standard establishes an ultimate proving ground, a 140-kilogram sandbag built with a solid hemispherical bottom to concentrate force, is violently hoisted by a crane to a height of 12 meters above a suspended net. As that heavy sandbag hangs completely still in the air, it represents the fatal vacuum between safety and the lethal impact. These safety nets operate as highly engineered kinetic shock absorbers. Their right to exist on a job site is proven only by surviving this extreme simulated drop. Let's examine the chemical composition of the net waiting below. Freezing the action as the crane releases the weight, we push into the microscopic structure of the woven fiber, revealing dense, embedded protective particles. The standard mandates the use of man-made fibers possessing specific tensile properties. Standard polyethylene is explicitly banned from use because it cannot reliably handle sudden massive structural stress. The square or diamond mesh is limited to exactly 10 centimeters from knot to knot. Furthermore, a 2007 amendment requires these knots be heat set under tension. This thermal locking ensures the knots slip no more than 10% when a massive, sudden load is applied. This precise combination of internal chemistry and rigid heat-set geometry is exactly what prevents the net from tearing apart upon initial contact with a falling mass. Watch this generated simulation as we resume real-time. The 140-kilogram weight violently strikes the exact center of the mesh in ultra-slow motion. The required initial sag dictates a downward curve at a 1:5 ratio to the shorter side, acting as a shock absorber. During a 12-meter drop impact, the net can stretch downwards up to 2 meters, safely decelerating the massive weight. As the center drops, the thick border and tie cords must successfully transfer this massive burst of kinetic energy out to the rigid supporting framework without snapping. A successful, life-saving catch relies entirely on controlled, calculated deformation to absorb fatal energy. This photograph captures the heavy smoke and looming chimneys of an industrial plant. These nets operate in punishing environments, exposed to constant industrial elements and brutal weather. Appendix C of the standard outlines the invisible chemical threats present at these sites: ultraviolet light, sulfuric acid, and concentrated phenols slowly eat away at the polyamides and polyesters within the ropes. They also face the physical dangers of extreme heat. Molten metal sparks falling from high-altitude welding equipment can permanently weaken the synthetic fibers on contact. Surviving the massive drop test in a pristine facility is only the first hurdle. The true engineering challenge is maintaining that baseline strength against constant, invisible environmental degradation. The standard enforces strict maintenance rules to verify survival. Competent personnel must conduct weekly inspections to identify external wear, abrasion, and filamentation, which is the physical fraying and breaking of individual outer fibers. The net also utilizes woven-in test cords. Every 3 months, one of these designated cords is extracted and mechanically strength tested to ensure the invisible chemistry hasn't failed. A dusty construction net looks entirely mundane. Yet the preamble of the standard document anchors the equipment's purpose with a phrase from the Mastor Kisan Shakti Sangathan, the right to live. Industrial safety nets act as highly tuned, actively maintained engines of survival, standing between workers and the fatal vacuum below.